Here we are on page 15 with the numbers 14 through 19 here at the end. We're going to be using instantaneous velocities and averages, which means we're going to be using a derivative. We don't have enough time here to go through the entire derivation of derivatives. That was a math pun, but we are going to use them. And so if you don't know how to do a derivative on a polynomial, something like x to the fourth plus 3x cubed. We're going to use this one the most where we're dealing with all polynomials down here. The standard rule is a shortcut to a lot of time in a beginning calculus class is that it's going to be 4x to the third. So this comes down in front and it drops a power plus 9x squared. And if you have something like plus a 2x, that becomes a 2, and then plus 17, that's a 0, because this is an x to the 0 out here. So that's the standard rule that we're going to be using. So keep that in mind if that's a review for you. If it's not, you really need to take a little calculus and learn a derivative. The next thing, here we have position functions. So I want you to imagine like a number line or a thermometer headed up here measuring some height. Make it a number line. There's 0, there's -1, -2, and 1, 2, 3, 4, stuff like that. And what this is saying is where is its position at time t? For example, if you stick t in as 0, you're going to be right here at time equals 0. So it's like that's where they started the clock. And then at t equals 1, you get 3 times 1 minus 7 is a -4. It's down here at -4 at t equals 1. So after 1 second, it's like a snapshot. It moved from here to here. And then at t equals 2, you have 3 times 4 minus 14. So 12 minus 14 is -2. So it must have bounced back up, and it's coming like this. So its path is going like this and then back up. And so it's traveling somewhat along this line. And at certain times, I'll put that in time t equals 2, you get this. So when it asks average velocity, it's actually same thing as up here. This is going to be in feet per second or miles per hour. Well, we're using up time here, so we need to see how much distance got moved in this much time, and that's where we get the average velocity. One more little comment about velocity is it is not exactly the same as speed. Growing up, we think of those two as really the same thing. Speed is always a positive number. Whether you're going forwards or backwards or up or down, you're traveling at 20 miles an hour or 30 feet per second. Velocity includes the direction. So yeah, when the guy is headed this way, his velocity is a negative. When he's headed that way, his velocity is going to be positive. And it allows in things such as physics to have a direction associated with it. Because a ball hitting a wall going that way compared to bouncing back has a very different impact on how much force the wall is experiencing at that time, or something like that. So velocities can be negative in this particular scenario, or they might actually be off in a different direction. So that's the big difference. Is speed is simply how fast you're going. Velocity is how fast you're going in what direction. So with that little bit of a background, let's get to it. So we need to find the average velocity. We'll do 14 in green from t equals 2 to t equals 4. So number 14, s of 2 is going to be 3 times 2 squared minus 7 times 2. We did this one up here. 3 times 4 is 12 minus 14 is a -2. Yeah, at time 2 he's here. At time 4 he is 3 times 4 squared minus 7 times 4. 3 times 16 is 48 minus 28 is 20. So at time equal 4, he is way up there. So you can see in those 2 seconds or minutes or whatever happened between time 2 and 4, he zipped way up that line. So how fast was he going? It's 20 minus a -2. So he moved 18 feet or miles or yards over that 4 minus 2. So he moved 18 in 2. 18 miles in 2 hours or 18 feet in 2 seconds. We're not given the units here, but the average velocity is 9. So it's the same thing we did up here. We just found slope, y minus y over x minus x, so to speak. Instantaneous, this is different. This is like he had a little speedometer on his little body as he's going zoom, 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 moving around. This is how fast was he going at t equals 1. Now you'll notice at t equals 1, he's down here, and what, did he turn around right there? Or was it a little bit further that he turned around? How fast was he going? This is where a derivative, this is where you do s primed of t. This is a derivative that finds the slope at an instant. So we're going to do s primed of t, and it is, take the derivative of this, 2 times 3 is 6t, drop it down a power to 1, minus 1 times 7 is 7, t drop down a power, 6t minus 7. And it says at t equals 1, so we stick in 1. S primed of 1 equals 6 times 1 minus 7 equals a negative 1. So at this moment in time, he's still headed that way at 1 mile per hour. So S primed of 1 is a negative 1, or feet per second, whatever it is there. Okay, number 15. Here we have, we'll do it in this orange color so we can see that. So we're going to do S of 0 gives us 0 minus 0 plus 7 is 7. Good. And S of 2 is going to equal 5 times 2 cubed minus 13 times 2 squared plus 7. 5 times 8 is 40 minus 13 times 4. 13 times 4 is 52 plus 7. 40 minus 52 is negative 12 plus 7 is a negative 5. So in these 2 seconds, he went from the point 7 way up here down to the point negative 5. So we take negative 5 minus 7 over 2 minus 0, y minus y over x minus x. And we get negative 12 over 2 is a negative 6. So his average velocity in that case, ooh, that's a negative 6, yeah, was headed that way at 6 miles per hour or feet per second. The velocity is negative, telling us he was headed backwards on average during that time interval. So instantaneous at t equals 2. So we're going to take s primed of t, and that is, let's do this rule, 3 times 5 is 15 t squared, minus 2 times 13 is 26t, plus 7, that goes down to 0. So now let's stick in s primed of 2. So this is what we want, where t equals 2. It's going to be 15 times 2 squared minus 26 times 2. That is 15 times 4 is 60 minus 52 equals 8. So at that exact moment, he's actually headed up with a speed of 8. So velocity is positive 8. So he's headed upward at 8. Good. Let's get a little bit of space here for the last one. Number 16. So the average velocity from t equals 1 to t equals 4. So let's do s of 1. We're going to do 1 to the 4th minus 4 times 1 cubed plus 2. And that's 1 minus 4 plus 2. 1 minus 4 is a negative 3, plus 2 is negative 1. So at s of 1, he's at negative 1. So here's your time equals 1 for this guy. He's right there on the line. And time equals 0, he was up at 2. So, ooh, he went backwards. That's at time equals 0. So what does he get at time equals 4? I bet he's going to be huge. 4 to the 4th, yep, that's big. Minus 4t cubed, oh, that'll shave him down a bit. And then plus 2. So 4 to the 4th is 256. Oh, this is a 4 times 4 cubed. So that's minus 4 times 64 is 256. Oh, look at that. They just canceled out. That's nice. And we get 2. So at time t equals 4, he's right back where he started from. So we take y minus y over x minus x. So 2 minus minus 1 is 3 over 3. So his average speed from, or average velocity from here up to here, yeah, see, he went up 1, 2, 3 in 3 seconds. That's why his average is 1. And now instantaneous speed at time t equals 3. Now remember, at time 1 he's here, and time 4 he's here, But he might have gone way up here and then way down here and then just ended up back there. We don't know yet. Let's find out. So the instantaneous velocity at time 3, let's do it of t first, general form, and we get 4t cubed minus 12t squared. So yeah, we did 4 down in front, 4t, drop that a power cubed, minus 12t squared plus 2. All right, so now let's stick in that 3 and see what we get. 4 times 3 cubed minus 12 times 3 squared. And we get 4 times 27 is 108, minus 12 times 9 is 108. Oh, wow. 0. That means at time t equals 3, he stopped. He went up and he turned around. So we caught him right at like that point, or right at that point, or something like that. That is where he is stopped. That's kind of cool. And finally, we are down here on number 17 through 22, tangent lines. It says write the equation of the line. All right, stop right there. When you write an equation, you need two basic things. You need a slope and you need a point. We'll call it x1, y1. And you remember how to do this with point slope form. And there's also a slope intercept or standard form. But point slope form, you wrote it out as y minus y1 equals mx minus x1. And the other way of doing it that was kind of slick was standard. Now you can solve this for y equals mx plus b, but the standard form, m equals negative a over b, gave you ax plus by equals, and then you plug the point in to get your c right there. So we'll use both of those. Now, how does this connect to what we're doing here? Well, you're going to get this point. The point is going to come by sticking it in. I'm just going to call sticking. Yeah, if we stick in 2, we'll get the y value. 1/2, we'll get the y value. 9, we'll get the y value. You just stick it in. The slope comes from the derivative. That's what gives us the instantaneous velocity from this one, or the instantaneous or tangential slope for these ones. So with that background, let's start it up. Number 17. P of x equals 3 halves x squared minus 7x. So the first thing we're going to do is get the point. It says that x equals 2. So at 2, we have 3 halves times 2 squared minus 7 times 2. That's going to equal 3 halves times 4 is 6 minus 14 equals a negative 8. Hey, look at that. That was pretty good. 2, negative 8. That's our point right here. So we have the point 2, negative 8. Now, how do we get the slope? Well, derivative. P primed of x is 2 times 3 halves is 3x and minus 7. Yeah, look at that. We took the 2 times the 3 halves, dropped it a power. 1 times 7, dropped it a power. 3x minus 7. So if we stick 2 into here, so at the x value 2, our slope is 6 minus 7 equals a negative 1. So here is our slope, and here is our point. Now I want to put this on a calculator just this once so you can see what happened and what we just found. So if we go on and go to y equals, and there's our thing right there, 3 halves x squared minus 7x. So let's look at a graph of what this looks like. Ooh, look at that little parabola there. Now, if we go to the table, we'll see, oh yeah, look at that. 2 is a negative 8. There we go. That's the point. Back at the graph, 2, negative 8 is right here. And what this is telling us that the slope right at that point is a negative 1 slope. So we're looking to graph that exact line. So it looks kind of like this. We have something going in like that. I think it went through the origin. 2, negative 8, and it's this line right here that we're trying to graph. So let's put that in. In point slope form, we would get y minus a minus 8 equals negative 1 x minus 2. So that's one way of writing it, or we could use the standard form, which was, this is negative 1 over 1, so that's x plus y equals, and then stick 2 in for x, negative 8 in for y, and get negative 6. Either one of those, or if we solve for y equals mx plus b, we get y equals, let me see, subtract 8 over there to a positive 2, and we get y equals negative x minus 6. So there's y equals mx plus b, standard form, and point slope. We won't spend as much time seeing all three of those forms of the equation. The real issue here is making sure you can get the slope and the point to be able to write that equation of the line. All right, let's try number 18. So we have f of x equals here at x equals 2. So at x equals 2, we now have, what's f of 2? Let's figure out what our point is. So 3/4 times 2 cubed minus 7. And that's going to be 3/4 of 8 is 6 minus 7 is a negative 1. So the point is 2, negative 1. All right, what's the slope? Well, we got to do f primed of x, and then we'll stick 2 in there. 3 times 3/4, that's 9/4 x squared minus 7. And stick in 2, we get f primed of 2 is 9/4 times 2 squared minus 7. That's 4, 4. 9 minus 7 is 2. So the slope is 2 over 1. So we can stick this into an equation. I'm going to use this ax plus by equals this. That's my favorite. So we're going to have slope is 2 over 1. So that's 2x minus y. Again, opposite sign in the middle. And then stick 2 into x, and we get 2 times 2 is 4, minus a minus 1 is a 5. There we go. Let's write these down over here to keep them before we erase everything. We get x plus y equals a negative 6. And over here, we get 2x minus y equals 5. Good. All right, let's get some space here. Number 19, g of x equals x cubed at x equals 1/2. So first of all, we have to find the point. G of 1/2 equals 1/2 cubed. So our point is 1/2. That equals 1/8. 1/2, 1/8. Ew, that doesn't look like a very fun point to stick in. Yuck. So, well, we're going to do it anyway. Oh, well. And let's get the derivative. So g primed of x is going to be that 3 comes down in front, 3x squared. So when we stick in g primed of 1/2, we're going to get 3 times 1/2 squared is 3 times 1/4, 3/4. So the slope on this guy is 3/4. Let's do the point slope form. On this one, we get y minus 1/8 equals 3/4 times x minus 1/2. Let's go ahead and solve that for y equals mx plus b. This jumps in here, and we get 3/4 x minus 3/8, and then we're going to add the 1/8 over, plus 1/8. So this gives us y equals 3/4 x minus 2/4, which is the same as, 2/8, minus 2/8, which is the same as 1/4. So there we have it. Y equals 3/4 x minus 1/4. All right, that's number 19. All right, let's do number 20 now. Number 20 has, this is kind of an ugly looking one. It has fractions here, but let's do it anyway. H of 0 is, oh good, we got rid of the fractions. We stick in 0, we get 0 plus 0, 0 to the 5th over 7, plus 0 to the 3rd, plus 7, and that's going to equal 7. So it means we go through the point 0, 7. For those of you that remember y equals mx plus b, that is b on our line. We're going through 0, 7. Now, h primed of x, see what happens, what's the derivative at this point? And this becomes 5 times 1/5 gives us just x to the 4th, drop it a power, plus 3x squared. Okay, and now stick in 0. H primed of 0 equals 0 to the 4th plus 3 times 0 equals 0. So our slope is 0. That means we are at a horizontal line, so it's just y equals, and we go through the point 0, 7. So y has to equal 7. This is a horizontal tangent line. Let's pull that up on the calculator just to make sure we see what's going on. And right here, here's x to the 5th over 5 plus x cubed plus 7. Now when we graph this thing, yeah, notice what happens. This thing comes up, and as we hit 0, 0, 7, let's make sure that's true on the table. Let's go up to 0. Yep, 0, 7 is actually a real point on the graph. And then when we graph it, it is, yeah, it turns out that that thing is exactly flat right at that point. It has a slope of 0. So this line y equals 7 would be tangent right there. It would also cross through it. Alrighty, good. Let's do the last couple. Number 21. K of x equals square root of x minus 1 at x equals 9. So let's do k of 9. First of all, let's get our point that's actually on the graph. That's square root of 9 minus 1. That's 3 minus 1. That is 2. So we stick in 9 and we get the point 2. 9, 2 is on the graph. Now the slope, we got to do k primed of x. It may be helpful to think of this as, if you remember k of x, this is x to the 1/2. The 1/2 power is how we write radicals. So k primed of x is going to be 1/2 x to the negative 1/2 minus 1. That's 1 over 2 square roots of x. Remember, negative exponents, just put it down on the bottom, minus 1. So the slope at 9, x equals 9, is 1 over 2 times the square root of 9 minus 1. So that's 1/6 minus 1, negative 5/6. Great, so this is our slope right there, and that's our point. Let's write the equation of the line. I'm going to do that ax plus by. So we get 5x plus 6y equals, stick in the point 9, 2. That's 45 plus 12 is 57. And there's our answer. 5x plus 6y equals 57. Cool. Number 22. M of 2. So if we stick it in, we can get our actual point. That's 2 cubed minus 3 times 2. Oops, put a square there. 3 times 2. There we go. 2 cubed is 8 minus 6. So 2. We get the point 2. 2 is actually on the graph. The slope comes from the derivative. M primed of x is going to equal 3x squared. That 3 comes down to the front, and then it drops a power, minus 3. And that equals, sticking in 2, m primed of 2 now, gives us 3 times 2 squared. That's 12 minus 3 is 9. So the slope is 9. All right, so when we write this, let's go ahead and use the, I don't know, point slope form. Is that all right? Y minus y1 equals m x minus x1. And so we get, jump that in, we get 9x minus 18, and then we're going to add the 2 over there. So we're going to end up with y equals 9x minus 18 plus 2 is minus 16. Y equals 9x minus 16. There we go. And that will do it for the calculus intro.